Okay, so now that we've introduced trees, now we're going to take a look at a specific type of tree called a rooted tree. So the idea of a rooted tree is that you're going to pick a vertex to be the root and designate it as that, and then direct all of the other edges away from that vertex that you picked. So let's look at an example of a tree. This is a tree that we looked at in the previous video, but now I have labeled its vertices so we can refer to them by name and kind of track where they are going to go. Because we're going to take this tree and we're going to rearrange it, starting by designating one of these vertices to be the root. Now I can pick any one of these vertices, and picking different roots would produce different rooted trees. So for this example, I'm going to pick D and have that be my root. So now I'm going to rearrange this graph. I'm going to put D at the top. So there's D, my root. Now, traditionally you put the root at the top. Some people put the root at the bottom. But the idea is now we're going to take all the other edges and direct them away from that D, from that root. So I can see adjacent to D, I've got C and E. So I'm going to put C and E down here and have the edges become arrows going like that. So there's C and E. Now E is a dead end, so there's nothing going to be coming down further from E. But for C, I can see C is then adjacent to B and F. So I'll put B and F beneath C and have those edges directed away from the root, so that I'm forming paths, directed paths now, going away from my root. Finally, A is adjacent to B, so I'm going to put A on the next level down, and I have one more edge directed away from that. So now that is a rooted tree. It's by nature, it is a directed graph that you kind of obtain from a tree. Trees initially are undirected graphs, and the underlying undirected version of this is a tree. But a rooted tree technically is directed. However, arrows are usually omitted, since the direction of those arrows is kind of implied by which vertex you chose as the root. So the arrows are omitted because they're kind of unnecessary. But we do usually represent a tree in this structure with this sort of downward cascading structure, and we arrange those vertices onto levels, which I'll define in a moment. So let's take a look at another example of a rooted tree and go over some vocabulary associated with rooted trees in particular. So here's a rooted tree, and I've labeled all these vertices. The first thing we'll say here is R is the root. So there's our first vocab word, already introduced, already defined. It is the root. It's at the top. Now, I'm gonna define the rest of these vocab terms from the perspective of one of the vertices. So I'm going to imagine that I am vertex V. Okay, and now from the perspective of vertex V, I'm going to sort of name a bunch of other things relative to V. So the first would be the parent. The parent of V is the vertex directly above it, that it sort of, we have a directed edge coming from that vertex to V. So Y is the parent of V. Vertices have a single parent, and that parent is unique. You could prove that. In fact, I think I've asked you to do so on your assessment. So Y is a parent of V. Next, we have children. If you have parents, you can also have children. Now, you can have more than one child. So with vertex V, the vertices beneath V directly are children. So A and B are the children of V. Speaking of parents and children, we can also have siblings. If two vertices have the same parent, they are siblings. So in this case, U and V are siblings. Remember, I'm doing everything from the perspective of vertex V, but you could also say like A and B are siblings, or X and Y are siblings. And then we can also talk about ancestors and descendants. So ancestors of V would be any vertex which is in the path from the root to V. There's always going to be a path to any vertex in the tree coming from the root. That is something you can guarantee. There'll always be a path from the root. And vertices along that path are ancestors. So in this case, R and Y are ancestors of V. And then anything that you can, any vertex you can get to along a path that passes through V on the way there, those are called descendants. So in this case, A, B, and C are our descendants of vertex V. All right, so all of that vocabulary kind of stems from, families, but we also have some vocabulary for trees, which comes directly out of, like, plants, botany. So some of these vertices you'll notice don't have any children whatsoever. Those are called leaves. So the X, U, A, and C are our leaves in this tree. And the other vertices are called internal vertices. They are closer to, the middle of the tree, so to speak. So R, Y, V, and B are internal vertices. Just going to check that I'm arranged. Yeah, okay, you can see that. Good. Right at the bottom of the screen. It's okay. A vertex in a tree is either a leaf or an internal vertex. Those two categories partition the vertex set of a tree. One more vocab term here. If you pick a vertex in your tree, you can form a subgraph rooted from that vertex. And that's called a subtree. So subtree rooted at V would look like this. It would have vertex V, and then it would have all the descendants of V coming off of there. So we've got A and B, and then B would have C as well. So it's like if you were to come along and snip that tree, cut it right just above V, and then take that is a subtree. All right. This idea of subtree is kind of analogous to the biological idea of a clade in cladistics, which is a way of studying evolution and like the sort of tree of life. They talk about looking at different species and the sort of ancestors of those species and the common ancestors of those. Common ancestors would be like where the subtrees kind of meet, and then if you can snip that tree of life and form a subtree that contains different species, those species are said to be in the same clade. So if anybody's into biology and know about cladistics, there's a connection here to trees. Okay, so that's it for rooted trees and vocabulary. We're going to look at a special type of rooted tree in the next video called an Emery tree.